We left off last episode just as opportunity was arriving at Victoria Crater on Sol 951, Sol being the term for a Martian day. This by itself was a remarkable achievement, considering opportunity was only designed to last 90 sols. During those 951 sols, it had already achieved so much. By examining many different rocks in various locations along its journey, it was providing a host of data to determine if there used to be a water ocean on Mars in the past. During this journey, it had become stuck in sand dunes on numerous occasions, but each time it persevered and freed itself. Some of its parts had begun to malfunction, but engineers had been able to implement workarounds, which meant opportunity has been able to go on unhindered. It also survived dust storms that lasted for days on end, but thankfully it was always able to charge its batteries up again afterwards. So what was so interesting about Victoria Crater? Was it able to provide any valuable information about Mars that opportunity hadn't picked up anywhere else? I'm Alex McColgan and you're watching Astrum, and together we will go through everything opportunity did and discovered around the Victoria Crater. Victoria was always going to be an important landmark for opportunity to reach. Although few thought opportunity would last the 7-kilometer journey from its initial landing site. At this point, opportunity had lasted more than 10 times longer than its original design lifespan. Victoria is the biggest crater opportunity had visited yet, being 730 meters wide. It was also the deepest, meaning ancient bedrock outcrops along the walls of the crater were exposed to the surface. Exposed bedrock contains the clues to Mars's past that opportunity was looking for. Also, as you can see, Victoria made for an impressive sight, especially in contrast to this otherwise flat plain that opportunity had landed in. In preparation for this new exploration site, mission controllers uploaded new software to the rover, which would enable it to decide whether to send back an image, or to extend its arm in preparation to sample an interesting rock outcrop, and even improved the intelligence of the rover to detect obstacles it should avoid and to make its own path around them. These features save a lot of time for mission controllers, who would have had to have gone through hundreds of images and wait through painful latency delay for commands to be sent to the rover. At its furthest point, latency between Earth and Mars can be upwards of 40 minutes. This is one of the reasons why it took 3 years to only travel 7 kilometers up until this point. To test this new software update, mission controllers had opportunity drive towards a patch of rubble, and settings were adjusted to make opportunity think that this rubble was a no-go zone. In reality, the biggest of these rocks is only 10 centimeters tall, meaning opportunity could have easily driven over it, but they didn't want to test the systems on something that could actually damage the rover if it went wrong, so they chose these rocks instead. As you can see, the rover adjusted its course around the dangerous area and took this panorama so mission controllers could see how the rover responded to the new program. Opportunity began to circle the outskirts of the crater, imaging it as it went. It came across a few cliffs or capes along the way, imaging them with a very clever technique called a super resolution mosaic. These images have a much higher resolution than the camera on board Opportunity is capable of, and the way they did this is by taking lots of photos of the same thing, and then in post-processing on Earth, they combined the images to provide the resolution you see here. On a side note, this technique is used in many different fields, including microscopy and astronomy. Scientists say that the layers you see in the rocks found in all these cliff faces are due to a geological process called cross-bedding. They believe these layers are ancient sand dune deposits, which is why the lines are inclined upwards and not just horizontally. From these lines, they predict that this used to be a sand dune field, not unlike the Sahara Desert on Earth. Now, while this science data was very useful, mission controllers were primarily looking for a passage down to the crater floor, and they thought they found one here at the Valley Without Peril. On closer examination though, it was decided that the slope was too steep. Opportunity investigated a couple of cliffs while it was there, and even came across another meteorite called Santa Catarina. Before mission controllers decided to drive the whole way back to the original arrival point at the crater to try and get down by there. This site was chosen because the slope was within the safety limits of the rover, plus the ground was made of flat, exposed bedrock, which meant it wouldn't have much wheel slippage. On the 28th of June 2007, or 1,200 sols into the mission, Opportunity prepared itself for its descent. But just as it perched itself on the top of the slope, the biggest dust storm Opportunity had seen yet rolled in, decreasing the brightness of the sun by 96%. That's not quite as bad as it sounds, as the dust also scatters some of the sunlight towards the rover too, meaning it was generating roughly 128 watts on the darkest day, compared to its usual 700 watts on a clear day. But this is bad news for a solar-powered rover. That kind of power level isn't enough to keep the rover going. In fact, anything under 150 watts means the batteries begin to run flat. So, operations were cut back substantially until the storm was over, and Opportunity was only commanded to communicate back to Earth once every 3 days. If the batteries did run flat, the components on board Opportunity could be damaged due to the intense cold on the planet during the night. Typically, the motors have heaters powered by the batteries during the night to keep the motors warm. If the batteries run flat, there would be nothing to stop there being extreme temperature differences between night and day. At the equator, anywhere up to 20 degrees Celsius during the day, and minus 75 degrees Celsius at its coldest at night, which would damage the sensitive components. The reason for this temperature variability is because although Mars does have an atmosphere, it is 100 times thinner than Earth's, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. Going back to the batteries, if they reached a critical level, Opportunity was also designed to trip a low power fault. This basically disconnects the rover's batteries from all but the most essential systems of the rover, putting it to sleep as it tries to charge its batteries with whatever available sunlight there is. Every sol, the rover would check the battery level to see if it could reconnect the other systems, and if so, it would then re-establish connections with Earth. This low power mode could mean the rover stays asleep for only a few days, but it could also go on for weeks or even months. Chances are that at that point, even if it did switch back on, too many of its components would be broken and it wouldn't be able to function anyway. Back to the dust storm at the start of July 2007, mission controllers initially thought that it would only last a week, but by the 15th of July, the storm had reached its peak. These are true color images showing a time lapse of the storm, and as you can see, it does get very dark. Thankfully, the severity of the dust storm was not quite enough to trigger the low power fault this time, although it did get worryingly close for a while. Eventually, by the 21st of August, or Sol 1271, the storm had cleared enough so that Opportunity could start to move forward again. Sol 1291 saw Opportunity finally enter the inner slope of the crater. But like it did before with the previous crater, just after it entered, it backed out again to assess the amount of wheel slippage from the slope. As it happened, wheel slippage did exceed the mission controller's threshold of 40%, so the rover stopped with 2 of its wheels still over the lip of the crater. After 2 days of decision making, mission controllers decided to press ahead regardless, and an extended exploration into the crater began. As Opportunity descended, it took some time to investigate any interesting looking parts on the exposed bedrock. It also took some images of the cliffs either side of it. I think these images showcase just how steep the slope is that Opportunity is sitting on, roughly 20 degrees. Opportunity didn't venture too far into the crater, as only sand dunes were found towards the base. It spent its time examining this light patch of bedrock, taking various pictures, and using its rock abrasion tool to investigate the rock's structure. It was determined from the data Opportunity collected that this area was likely not ever so hospitable to life, so mission controllers picked the next waypoint for their journey, Endeavour Crater. If you thought Victoria was big, look at this mammoth. Endeavour was thought to contain some clays, meaning water was once there, so Opportunity started its journey out of Victoria. At this point, on Sol 1502, Opportunity encountered another fault with its arm. No matter how much power they put into the joint, the arm wouldn't move from its stowed position under the rover. Sol after Sol passed, and the joint refused to move, until they determined the time of day the joint had the least electrical resistance, which was just at dawn before the heater for the motor switched off during the day. When that time came again, they put as much power as possible into the motor and it worked. Not risking ever stowing it away again, engineers had to determine how to maneuver the rover safely without risking damage to the arm. Opportunity then began its 2-year trek towards the Endeavour Crater, which we will save for the next episode. Ever wondered about the process of getting to faraway planets? When we think of a spacecraft hurtling through space, we often imagine them with their thrusters always on full power. But as Brilliant's daily problems explain, this isn't the case. So how do spacecraft travel through space? The problems Brilliant present give you the context and framework that you need to tackle it, so that you can learn the concepts by applying them. If you like the problem and want to learn more, there's a course quiz that explores the same concept in greater detail. If you are confused and need more guidance, there's a community of thousands of learners discussing the problems and writing solutions. These thought-provoking challenges will lead you from curiosity to mastery one day at a time. So what are you waiting for? Go to brilliant.org/Astrum and finish your day a little smarter. The first 200 of you to do so will get 20% off the annual subscription, so you can view all problems in the archives too. Thanks for watching. If you're new here, check out the previous 2 videos about Opportunity arriving on and exploring Mars. Subscribe so you don't miss out on anything in the future, and a big thank you to my patrons who have helped support the channel. If you'd like to support, check the link here. All the best, and I'll see you next time.